Hi, folks. Thanks for joining us. This is the first of our new series here at IBLIC that we're calling Bring Your Own Data, where experts and data meet. To tell you a little bit more about Bring Your Own Data, I definitely want to highlight that we're going to be going over best practices for having data discussions. In other words, how you can collaboratively analyze data with colleagues, with clients, and in every episode, we're planning to stream them live as connected remotely. So for those that don't know me, my name is Pete Nast, and I recently joined Einblick Analytics as head of customer success. Also joining us today is our guest, Tom Gorham of Rissho University and assistant professor over in Tokyo, Japan. And my colleague and co-founder here at Einblick, our chief of AI, Benedetto Baratti. To tell you a little bit more about our guest, Tom Gorham, as mentioned earlier, he is currently an assistant professor at Rissho University in Tokyo, Japan. He also is currently a PhD student, where I believe he first came across Einblick in his research around social informatics, specifically learning analytics, just to share a few highlights. With that, I'm going to pass the ball to Tom.
Yeah, great. Hey, thank you, Pete and Benedetto. Thank you very much. I'm really happy to be here for Einblick's BYOD today. Today, I'd like to talk a little bit about an app that I've been developing for my PhD research called Pebasco, which comes from peer feedback on spoken content. Now, what is Pebasco? Well, it's a prototype learning analytics platform, and the goal is to improve students' English skills by working on their peer feedback skills. It's a type of low stakes formative English practice. And really the central goal for it is to have the students accurately match teacher feedback comments on audio recordings of their peers. And how does it work? Well, students try to predict when a teacher has added a feedback comment by pausing at a certain timestamp in the audio and then adding a feedback comment at that point. And students can add multiple comments to each audio, and the more accurate they are, the more stars they get. Now, how do Pebasco's hints work? Well, students can use up to 3 hints to help them match the teacher feedback comments. Hint number 1 indicates how many teacher comments there are in the current audio. Hint number 2 conveys the timestamp for each teacher comment, along with a link which jumps to the audio player to that timestamp. And finally, if they use hint number 3, that displays the full audio transcript, all of the information for each of the teacher comments, including the timestamp, the link, the comment type, and also the error correction. And finally, how do Pebasco's stars work? Now, like I said before, students can make an unlimited number of attempts on this and for each audio, and the students earn stars for matching all of the teacher feedback comments successfully based on the number of hints that they use. For example, if a student uses 3 hints, they can earn up to 0 stars, even if they match all of the teacher comments. If they use 2 hints, they can earn 1 star, 1 hint, 2 stars. And finally, if they use 0 hints, that's how they get 3 stars. And you can see on the right that the color of the new attempt button changes based on the highest number of stars they earned for that audio. Now, for today, and one of the things that I've turned to Einblick for help on is the following goals for today's BYOD session. First and foremost, we'll start out by manipulating and transforming the data. Then second, we'd like to identify evidence of peer feedback skill improvement over the course of completing all 4 units. For the indicators of success, there's 3. First would be a lower number of maximum hints used before an attempt that earns 3 stars. Second would be a low number of false positives. And third would be engagement with the app. So the amount of time that they spend listening to audio and kind of their clickstream data on it. Finally, I'd like to identify interesting macro personality traits that are predictive of the improvement.
All right, perfect. So thank you for the intro, Tom. And now we can switch to the workspace. So share here. So now we are in the workspace together with Tom and Pete, and we're going to start the analysis. So Tom, which type of data set did you bring into the canvas?
Okay, so I've got the first data set that we'll use here is called Airtable. This is an export of most of the user data from Pebasco. So that would be things like uh, stars that they've earned, attempts that they did, things like that. So this will be kind of our central data set, would be the Airtable one.
Got it. So I can see there are the student ID, the unit, the audio, the number of attempts, and the stars. Is there any other columns that maybe we should pay attention, maybe annotations?
Right. So yeah, I think there's one thing that would be interesting is looking at the annotations and the possible comments. So that'll be the comments that the teacher had made. So I think if we can look at the kind of the ratio between the uh, annotations that the student made and how many that there were possible and how many they actually matched. I think those three will give us kind of a good metric about how students are doing on each attempt.
Gotcha. So probably one of the first thing that we can do on those two columns is to use the difference between possible matches and annotation. Can you tell me again a little bit the difference between those two?
Sure, for the difference between annotations and
Possible matches.
sure, sure. So what we've got here would be possible matches would be the comments that a teacher has made. So that would be how many teacher comments there are. Then with uh, annotations would be the number of comments that the student has entered. And then finally, the actual matches would be how many does the student match with the teacher?
Gotcha. So the first thing that emerged here, like just plotting the histograms of the distribution for the different session, is that seems that the maximum number of possible matches is actually 8, but I see that some student went put pretty a high number of annotations. Some of them put even 30 on one session. Is that allowed by the app?
Right. So you can do unlimited number of annotations, probably going up to 38 annotations would be an indicator that maybe a student is just starting out. They didn't understand how to do it and are just kind of randomly clicking on it, maybe out of frustration. So those would definitely be outliers. I'd say probably fewer than 5 would be kind of more
Good one.
standard number of attempts, I'd say.
Gotcha. All right. Do you have any question, Pete, on the data itself?
So far, I think I'm following along just fine. I'll speak up shortly as questions arise.
All right, perfect. So just to follow back on what we were saying before with um, Tom, maybe the first thing that we want to do is to manipulate and create new columns based on this annotation, the two annotation possible matches column. And so maybe what we can do is to use an expression, like a really simple expression that can allow us to compute this new column. So what I'm going to do is to give this new data, the output of this data frame, and create a new column. How do we want to call this? Like matches difference, something like that?
Yeah, I think that works. Yeah.
Yeah, perfect. And then what we're going to do is to have possible matches minus annotations. Yes, perfect. So let's run this. Let's see. So what you're saying is that if this number is negative, it means that the student made more annotation of the actual annotation that would make sense to have for that exercise.
That's correct. Yeah. So that would be, I guess we should term false positives.
Yeah.
And so a high number of false positives. I think maybe a low, maybe 1 false positive, 2 false positives probably isn't that negative of an occurrence. But if you get a really high number of these false positives, then that would show that that the students aren't really understanding where the teacher comments are being placed.
Gotcha. Yeah. So yeah, it's gonna seems that it's centered around 0, a little bit more than 0, but yeah, and there are some students that put quite a bit of negative matches, of matches more than necessary, all this area on the negative side. So it's kind of interesting. It's also interesting that some students put less annotation than actually there were in the exercise.
Right, right. So that may be an indicator that somebody had started an attempt and then uh, ended it without making any annotations. So
Yeah.
maybe they just played it and then gave up on it, or ran out of it, maybe got sidetracked doing something else.
Yeah. So, and the other thing that you were saying is try to measure how many annotations per second.
Yeah, I think that that would be good too. So if we're looking at this idea of students that are actively engaged with listening to the audio while they're making annotations, would be an indicator of kind of engagement with the app. Whereas I think if someone's just going through and clicking several annotations, trying to maybe brute force the system, because you in the current version of Pebasco, you're not penalized for false positives, so you won't get kicked out of an attempt for that. So that may be an interesting indicator about if there's a large number of attempts in a short period of time. So that may be a good thing to look at.
Is there like a column that contains how much time they took to finish the unit? Is it time played?
It would be time played, and that would be time played per attempt rather than per unit.
Okay, perfect. So maybe we can just, as we did before, we can do a simple expression, and then we can drag it here, the canvas, just this data frame, and then we can call this maybe seconds per annotation.
Mm-hmm.
Sounds good. And then this will be time played divided by annotations. So in this way, we know how, the seconds per annotation, how many seconds per every annotation on average they had during that session. So let's run this. Oh, it's giving divide by 0. Is it this because some student did not use any annotation at all? Is it that possible?
That is possible, yeah. So that if someone starts an attempt but doesn't actually ever, because it doesn't autoplay, so there's a possibility of starting an attempt but not playing the audio.
Gotcha. Okay, so probably we need to do some smoothing here. So I want to keep the structure because I think that flipping this kind of reduce the interpretability of this new column. But I'm gonna add a really small constant here just to avoid this division by 0. So if we are gonna see a very large number, it doesn't mean much. It just means that the student had 0 annotations, right? But in this way, we keep the structure and don't impact the rest. All right, so let's take a look to this table again. And maybe we can take a look to this second per annotation column that we created. So as I said before, there are some of the students that have pretty high range, so that's why we see 2 million, so on and so forth. Maybe what we can do is simply scroll this. So it seems that on average they take like 7, 10 seconds and like that, something like that. So there are really large numbers, and for the large numbers, essentially it just means that the student did not provide any annotation there. All right. So, is there any other manipulation that we would like to do on this data set?
So I think now we've got. I think the 2 additional columns that we've added are good, and I think maybe the next step then would be to start looking for some of the success metrics in here.
Gotcha.
Might be a good step. Yeah.
So, but what you were saying during the introduction is that the student can have multiple attempts. Is that correct?
That's right. Yeah.
So probably, in terms of, if I remember correctly, that your definition of success dependent on the fact how they behave across all those different attempts, essentially. So we need
That's
to
right.
kind of group and combine this in some summary statistics for each one of those units.
Oh, right. Yeah. So I think with this, and this is actually one of the things that that I'm really happy to have. I'm like helping with on this is that there's a lot of different kind of moving parts in this. So it would be looking at attempts where students earned 3 stars. Would be kind of that's kind of the baseline of were they able to match with the teacher comments in there. But we also need to think about how many attempts that they made on that audio and their usage of the hints while they're doing it. So, for example, if a student uh, automatically jumps to 3 hints, they're basically able to peek at the answers, and then how they act on the next attempt could be something like a very short amount of time and just entering in the annotations without really listening to the audio. And so that would kind of indicate a less engagement and less learning that's going on. And so I think if we're able to juggle this mix between the number of attempts, the amount of time they're spending per attempt, or per annotation, and how they're using the hints. And so I think maybe if we start thinking about kind of a ranking of what are the indicators of kind of the best performance versus weaker performance on that.
All right, that makes sense. So what I see here is that so we have the student ID. Probably maybe we need to do something to convert this to a string. But so unit. So there are 4 units. How many audio for units?
So each unit has 15 audios.
All right. So in total we have 60 audio session. And then here this column number of attempts is, so you could have potentially the same student doing the same unit and audio multiple times. And so here you like 4, this means that this is the 4th attempt.
That's right. So that may be an interesting metric too, is looking at how many attempts a student makes per audio too. That may be an interesting thing to look at too. That if it's really high numbers in there.
So
I noticed under data frames that we're tracking anxiety, and it'd be interesting to see if there's a correlation between attempts, the amount of attempts, and who's showing for anxiety.
Yeah, I think that that makes sense to me. And what I would like to do is, if we are able to define this kind of concept also of success that Tom was talking about, we can also use that table to find correlation with, for example, number of attempts or even like success, so that we can have like a better picture of this table that is just performance and then the personality traits of the student. But I think it's a really good point. We should explore it. All right, so maybe the first thing that I would do is also to keep in track of the number of attempts, if we want to build a correlation with personality traits, is to group by, probably really simply by student, and then unit and audio, right? So student, unit, and audio, because in this way we have the information for each one of those units. And then what we need to do is kind of select the columns. I would just, given there are like, we have 19 columns, just for the sake of, the analysis and for clarity, should we drop some of the columns that we don't think it's gonna be useful? Maybe, I know that we need like number of attempts probably.
Yeah, probably for right now at this point in the analysis, I'd say a lot of the clickstream data in the right half of the table, so things like play and pause and fast forward, maybe we don't really need to look at those right now. So I think we'd be okay with removing those for the time being.
Okay, yeah, I can see those. So let's maybe select them. I can go one by one. So I think that for sure we want to keep the student ID, the unit. Let me resize this. Yeah, so we have the student ID, the unit, and also the audio. Yes, so those are the columns that we're grouping by. Then I would say attempt looks good, and hints, and probably we have stars. So what would make sense here to have like stars and then the columns that we obtained before, like the
seconds per annotation,
yeah,
and the matches difference. Yeah.
that makes sense. So for this one, I'm actually curious about what you think about those different columns, because if you think about hints themselves, we can aggregate this in two different ways. We can either have the sum of hints across all the attempts, so that will tell us how many hints they use. We can also use the max, so it's going to tell us for the session for which we have the most number of attempts, or just an average.
Probably with this, so that if we're looking at one audio, so if one audio would have multiple attempts per student, and so that if we're looking at maybe the maximum number of hints that are used in one audio, then that gives us kind of how much support are the students leaning on the hints for in that. So probably max hints per audio would be a really useful metric to look at.
This would be like the session in which they ask most of the hints. Yes, that makes sense to me. And probably same thing about stars.
Right, yeah, because really, I think one of the big metrics that we'll be looking for is, were they able to reach 3 stars at some point in an audio? So yeah,
that makes sense. All right, and then for the other one, in this case, probably we care about the. Here we have. Let me make this a little bit bigger. So here we have seconds per annotation, and here we have the matches difference. And so for the matches difference, if we want to align with the other metrics, we should probably pick the minimum, right? Because the smaller the number, the worse the attempt was, right? So we can do min here. And then seconds per average, if we want to catch if they are just putting a lot of annotations, right? Like probably they're going to spend a small amount of seconds for each one of those annotations. So I would do min also here. I don't know if that makes sense for you.
Right. So this, I guess it's kind of interesting, because would that be, because if a student has maybe one attempt that is kind of just a frustrated one where they're just kind of clicking through, but then has maybe multiple attempts after that that are kind of more focused and actually more kind of like actively engaged with it, would minimum end up pulling out those kind of like frustrated outliers in there? Or
yeah, or like, like that would be an explanation, right? But it's hard to distinguish from a session from which the student just clicked because it was frustrated, and another one from which the student just clicked because it wants to brute force the problem, right? So that's why I was suggesting min, and maybe we can also revisit this.
Yeah, let's start out with min and see how that goes then. Yeah.
All right, so I think we are in good shape here. Is there any other attribute that would make sense to add to the analysis?
Let's see. So we've got the attempt number, average attempts for the audios. Yeah, I think this is good. So we've got our stars, our hints. Yeah, I think this gives us a good base to start looking at the success criteria. I think.
So one thing that I would like to do as a starter, because now we have the min. So the worst session that the student had for each of the audio. Would it make sense for you to just plot, just to set the context, how this evolves in session one, unit 1, unit 2, unit 3, unit 4, and so on, just to see if this number goes up or down?
Yeah, definitely, because I think one of the things I'll be looking for is kind of this change from the first unit to the fourth unit, and seeing how are there some patterns that emerge after using the app over time.
Gotcha. All right. So let's give it a try with this. So I'm gonna pull this table here. It's already grouped, and so what I want to do is just to keep 2 columns, units and the match difference, so that we have this for all the sessions. We can also directly plot unit, right, and then pick the other one. In this case would be matches difference, and then say something like average, something like that. So max. So in this way, we can see that we get the most negative number at the first unit, and then it goes up. We can also do a similar plot for number. I just need to add a new column. Number of attempts. In this case, actually, I just noticed that we missed this one, because if we have number of attempts average, it's just gonna tell us like a number that's not really meaningful. What we want here is probably max, so that we know how many attempts they did for that audio.
Right, that makes sense. Yeah, because because this is split up by audio on that, then the attempts would only be just the one number of attempts per audio, then, right?
Yep. Yeah. So yeah, maybe we can also plot this. Would be interesting. Attempt max can produce the same thing. Actually, I'm gonna duplicate this number of attempt max. Now we can do what makes sense here. Do average. Yeah. It seems at the beginning they definitely do more attempts on average across all the units. This kind of plateaus after probably the second one.
That's good to know that may be an indicator of either learning how to use the system and being maybe unsure of how it works at the beginning, or it may also be an indicator of kind of actually learning how to identify the teacher comments in there. So
yeah. All right. So what would be the next step to this analysis? What would make sense for you?
Well, what would be really useful for me, I guess, to dig deeper beyond just the number of attempts on this would be kind of these, if we could start to pull out attempts that are kind of high quality attempts. And so that would be attempts where, audios where at some point the student's able to get 3 stars, but then in that, so that basically if a student isn't able to get 3 stars on an audio, then that means they didn't they basically didn't achieve what they needed to do for that audio. So I think if we can pick out the audios that have 3 stars on it, and then say if there's a way that we can find out how many hints that they used maximum before they got to 3 stars on that, would be kind of a good starting point, I think, about identifying if they're able to or how many hints they're using before they get the 3 stars.
So essentially what you're saying is, like, based on this condition would be 3 stars, or other conditions, we want to create a new column or something like that essentially tells us like this is a good session, like a successful section.
Yeah. And I think this idea of kind of like, if we look at kind of like the gold standard for this would be if a student's able to use 0 hints at 1 attempt and get 3 stars, would be they're able to listen to the audio 1 time identify the teacher comments and match them. That would be kind of like the best possible outcome, as long as they're not brute forcing it and doing multiple false positives that allows to get them. So it's kind of a little bit tricky, because if we're able to kind of keep an eye for catching that at the same time. So maybe if we're able to balance this, the difference, the match differences, plus the number of hints that they're using, because I kind of, if the gold standard is 1 attempt, 0 hints, and all matches and 3 stars, then maybe the next ranking down below that would be an audio where at the end they're able to get the 3 stars, but prior to that they have only used 1 hint and matched, and so they were able to get maybe use 1 hint, and then in a subsequent attempt they're able to do a 3-star attempt after that. So,
Gotcha.
and then beyond that would be using 2 hints and then subsequently getting 3 stars on a later attempt on that. And so kind of, if we're able to balance this lower number of attempts prior to getting the 3 stars.
We can explore a little bit and experiment what makes sense there. What I have in mind is to just create some like kind of new column, and this new column is going to be where we encode this concept that we're trying to define of success, right? So, and I think it's nice because in this way we can play a little bit with the different columns that we have and just see how this looks like. So how do we want to call this session, like a good session, like a golden standard, or a top
maybe
session?
Would it be something, maybe kind of like success or something like that, like success metrics or success?
Yes, perfect. And then let's say that the default being is going to be 0, and here 0 is just meaning that we don't consider it to be a successful session. And then we need to start defining some conditions. And so the first condition, that based on what you said, seems like that it would be for sure the number of stars they got at maximum. So are we looking for 3 stars?
Yeah, that would be right.
All right, perfect. So I just want to show you how this looks like. So, and then we can play with this custom binning operator. So this is going to be a new column called success. And so it's going to be 1. In this case, just if the maximum of stars is 3. Right, so,
and to clarify on this, Benedetto, is this then, by binning here, are we getting any audio that has at some attempt, it has a 3-star attempt within that audio?
Yeah, this one is just using one condition, which is has 3 stars in at least one of the attempts, but it's
within
not
one audio.
Yeah.
So that's really interesting. So what you've done here then is by setting it up first with the grouping beforehand, then with the binning, that's allowing me to pick and choose within these. That's actually really useful. Thank you.
Yeah. So this is like
in terms of making sure this is reproducible when we look at it later to understand what we've done here.
Yeah.
Is there any way maybe we could highlight a couple of these tables and visuals with some clarity on what we're looking at? For example, what you just did, maybe we could color that something and title it success criteria 3 stars.
So actually that's a good point. So let me do a real quick adjustment of the workspace so that we keep track of this. So I think the first part that we talk about is the kind of exploration data manipulation part, right? So I'm gonna use this data zone just so that we keep track. And I feel here we are in a different stage of the analysis. So I wanted just to mark this as data prep. And I'm gonna bookmark it real quick so that we can keep track of it. So rename this data prep, perfect. And then this one, as Pete, you were pointing out, let me also mark this area and then we can rename this as, maybe we can finish the analysis and then rename it based on what's the outcome. So let me change color here, and then so that our workspace is a little bit organized. I'm gonna keep this table in the middle because it feels that it's the connection point between those two parts. So far it's here, and this one you can create a quick annotation, say successful sessions. Yeah, perfect. Yeah, good point. Perfect. Yeah, so how do we want to transition here for the definition of success?
So our first bin is just looking at an audio where one of the attempts earned 3 stars. I think that's kind of our first one pulling this out. And so the table, the pivot table that you pulled out here shows that, what is it, about maybe
So
2 to 3 times the number?
Yeah, it's like one third are
Mhm.
session without 3 stars, and then 2/3 are session with 3 stars.
Oh, okay. And would that be sessions, or are we saying that that would be audios
Yeah, audios. Sorry.
per? So, oh, that's okay. So audios per students. So that's actually kind of an interesting thing just there alone, is that the number of if maybe 1/3 of the audios were left uncompleted by some students. So that would be almost kind of the like right now I think we found one where this kind of the opposite of a success indicator would be kind of these kind of a failed audio by students. So that's kind of a really interesting kind of surface level thing to pull out here. But looking on the success ones, if we start to dig deeper into these, that
The sessions.
what what else is happening in an audio when one of the attempts gets 3 stars? And I think if we could look at maybe the maximum number of hints that are used would be a good one to filter by, I think, or to bin by.
So let me add this condition, hint max, and how many hints do we want to use?
So for kind of the best, so I with this binning, can we look at the kind of multiple layers of binning on this, where we'd say that
Yeah.
kind of the best version of it, because that could be an interesting thing if we're able to assign kind of a numerical value for each kind of ranking of these, and kind of the gold standard one would be kind of a higher score on it, and then kind of the more hints that you get in. But maybe just to start with would be kind of like the best one would be maybe using maybe either 1 hint or 0 hints would be probably the.
So we can put 1 and update this. Let's see, yes. So actually the whole thing flipped, and that's kind of interesting because essentially it seems that a lot of sessions are using more than 1 hint, and I wonder if would you expect such a dramatic change? Because if I remove this, then it's completely the opposite. Right, like that there is a predominant number of sessions, but if I add the max, hint max, and I do something like smaller than 1, right, it completely inverts the result. And I wonder why. Like, it seems too dramatic. Let me.
Can we?
Yeah.
Sure. Can we up that from max hint from 1 to 2?
Yeah. Let's take a look. Yeah. Still seems pretty.
Yeah, that seems kind of unusual on that. That I think that
Oh, maybe I think that I know why. So it seems that because we are saying that we want sessions with 0 ints are actually good, right?
Hmm.
So what I'm seeing here is that actually the way the data was read is that 0 is computed as um, empty, right? And so that's why it's not getting computed. Yeah,
Oh,
yeah. So probably what we need to do is to add a small snippet. Let's actually add it here. So, so if we have 0, let me put it here. Oh, because actually the aggregation that we did before with number of tenths is problematic. Yeah, because if I have one that it's null, then max is gonna be null because it's not able to compute it. Yes, yeah. All right. So I'm gonna do a quick fix to this just to
hmm,
match what we want to do here. Um, and so to me, what makes sense here is that I'm gonna write a really quick snippet on the original table and then update the whole workflow. So let's take a look what happens. I think this should change what we're seeing. So we have df hints, which is the column that we want to change, and then say whatever is here that it's equal to hints, whatever is equal to null, then we replace it with 0, something like that.
great.
So let's take a look to this. All right. Just want to check that everything looks good. Yes, now we have zeros. Let's update all the pipelines. So everything is updating here downstream. We need to rerun this probably. This one is to be re-executed. So this one too, this annotate, this expression. Let's see. Yes, okay, perfect. Now we have zeros here, zeros there, and then if we go back here, then we shouldn't have this issue anymore. Let's take a look. All right, perfect. Yes. So now it makes more
Interesting.
sense.
Okay, so it was just empty cells in the table. That was the
Yes.
problem.
Yeah, it's just some data manipulation essentially. Yeah.
Great, great.
So what should we? Yeah. So it kind of rebalanced a little bit, but not as much as we were seeing before. Does it make sense to add other conditions?
Right. Yeah, I think we can also go into some other things in here. So if we're looking at the maximum number of hints being 1 hint, can we check and see what it looks like with 2 hints on there? Just
Yes.
briefly to see how that.
Yeah. 2 hints. You can also play with it if you feel like changing. So yeah, with 2 hints, you have this. So it's 41 against 58.
Okay.
All right. So what other conditions do we need to check? Like the number, or does it make sense that we start plotting some trends across the sessions? What I was thinking is maybe we can produce a similar plot to what we did before. On the x-axis, we have the unit. On the y-axis, just the percentage of successful and not successful sessions.
Yeah, I think that sounds good. And this is kind of just looking at really broad indicators of success, and then we can kind of put in some of the other hedges in there on top too. That things like the difference in matches and the number of seconds that go in, we can look at later.
Yeah, sounds good. So one second, I'm refreshing on my side real quick. Yeah, so what I'm gonna do is to use the same table, like same table that we use now, and then on the x-axis, I'm gonna use the units, and then on the y-axis, yes, the unit on the x-axis. Sorry, I need to go live back. Perfect. So I'm gonna drag this unit column here and then color it using the success column that we just created. And then maybe let's also normalize this. So right now there is a little bit of trend, right? It seems that the first sessions, they have a smaller percentage of successful sessions.
Mm-hmm.
Maybe we want to restrict a little bit more this definition, because I feel that, you know, if you're also including sessions that actually are not successful, then I think that we're mixing things that shouldn't be mixed.
Yeah, I think that's definitely. I'm sorry. Getting a little echo here.
Oh, my bad. I didn't mute myself. All right, perfect.
Oh, good. Okay. All right.
Mhm.
So I guess if we're looking at other kind of elements of the success criteria on there, then would be things like maybe the number of attempts that the students are doing in one audio, maybe trying to limit huge numbers of attempts would be reasonable. Also, we could look at the match differences and maybe not go for 0 false positives, but a low number, maybe 1 or 2 false positives, just to give a little bit of cushion for students would be okay.
So number of attempts, maybe do 2?
Right, maybe because I don't think we necessarily want to penalize for a multiple one. So yeah, maybe 2 or 3 would be okay on that.
Yeah, makes sense. Now we can again play with it, and then
Mhm.
the matches difference seems a big one. We don't want them to brute force the problem, so it needs to be bigger than maybe -2. So it means that they do 2 annotation more than necessary.
I think that seems like a kind of a fair way that gives the students a little cushion without being too strict on it. Yeah,
And
I think that
then,
sounds good.
oh, and then yes, I was forgetting about seconds per annotation. Here it's a little bit tricky. So for sure, we need to put some upper limit because of the trick that I did before to avoid division by 0. So I think that more than 6. How long is the, like? Do you think 60 seconds is too much as a for
Right.
audio?
So each audio is going to range anywhere from about 30 seconds to 60 seconds on it. So a 60-second pause in between annotations would be fairly high, I
Yeah.
think.
Yes. All right. So that would be our like upper limit. And then what you would think to be a suspicious behavior in terms of
It's-
lower limit?
Yeah, I'd say, if somebody's putting an annotation maybe once every 1 or 2 seconds would be kind of a brute force or a spamming technique on there. So I'd say maybe a 2 would be fine.
Gotcha. So let me run this. All right. So yeah, now the trend is pretty much clear now. There's actually a big jump between the beginning and the end in terms of the different percentages. And I mean, again, we're being a pretty relaxed with number of attempts in general. Like if we maybe change this number to something more stricter, that can be maybe 2, then yeah, this one is going to be number of attempts even 1. So if they're able to ace it, right, like they just did once. Oh yeah, here it's even more dramatic. So like those are really, really good sessions. Like the student did the audio, right, in just 1 attempt, got 3 stars without cheating on doing anything.
Right. Yeah, because I think then we're looking at if it's just 1 attempt, then this is kind of like the identifying the best possible version of kind of the gold standard of this. That then we're also saying that they're not I think we're cutting out the brute force or spamming behavior on there too.
Yeah. Yeah, so I think that's pretty interesting. Like, would it make sense now to just try to combine this table with which one was the personality traits one?
So the Hexaco one is a personality inventory.
Okay, perfect. And do we have a do we have a column on which we can combine this data set, or like in other words, like is there something that from which we can identify students in one table and the other one?
So with Hexaco, it has 6 major personality types in here, and in previous research, they identify one particular personality type that's called conscientiousness, and
Okay.
so it's kind of a personality type that's about kind of diligence, hard work, kind of those types of behaviors come out in conscientiousness, and research has shown correlation between the score that someone gets in the dimension of conscientiousness to a lot of different academic outcomes or educational outcomes. So that would be probably a good place to start from and see if there's maybe a correlation between kind of these performance on the kind of the gold standard versus the conscientiousness score on this, and it would be on a 5 point scale for conscientiousness.
Yeah, I'm taking a look to this. Yeah, all right. So, and then just going back to the connection between the two tables, like really on a technical level, like I can see that there is an email column here. Is that what we should use to combine with the student?
That's right. Yeah. So those would
Okay.
be the same student ID codes on there.
Gotcha. All right. So the first thing that I see from this data is that on one side, this is encoded as a string, which I think makes more sense because it's an ID, and in the other one as a integer. So I'm gonna do a quick modification to the data just to make them
Hmm.
compatible, and then join them. So I'm gonna do a quick type conversion, bring the data here, and then we have on this side, actually student should work, perfect. And then we convert this on as a text. Let's take a look here. And then going back to Pete's point, maybe I can create also update this one just to keep the workspace clean as we progress.
And so Pete had mentioned maybe anxiety. So I think anxiety is one of the
Yeah.
subsets of the personalities. So yeah, so that might be an interesting one to look at too.
So what we're gonna do is to use this table on the left and on the right, and then we can join them. Let me see here. Join, and on the left, we're gonna use the data that we just created now, doing the manipulation, and then on the right side, the Hexaco data, like the personality ones. I'm gonna do a left outer join, and then I'm just combining the two tables right now. So I'm combining them on student ID on the right and email on the left. Yep. And so let's maybe remove prefixes. All right, so let's run this and see how it looks like. So the first thing that we can do, Tom, is to take a look to what, the anxiety and attempts that Pete was talking about.
Mm-hmm.
And so we can take a look here, number of attempts, and right, so number of attempts, and on the y-axis we can have anxiety, right? So we can either do that, or we can also switch this to a scatter plot, but without aggregations, if that's possible. Yes. So, oh, so there is a granularity of 0.5 for those questionnaires, like the anxiety levels.
Right. So, as far as granularity goes, so it's on a 5-point scale, but I think with the averages, I'm not sure how
It's
if
gonna
it
be
goes down to
got it. Oh, so
0.5 scales or if there's
yeah,
finer
yeah.
granularity.
I can see that it is between like the granularity. It goes from 1 to 5, but it's the granularity is like 0.5 essentially. That's why.
Okay.
So there is. So this one is not super clear, so that the correlation seems not that much, but it might be also the visualization here. There is a little bit. If we want to get like a final response on this, let's just compute the correlation here. So I'm gonna select anxiety and attempts max. Yeah, so there is, but it's really subtle.
Mm-hmm.
Yeah, so it's really subtle. Yeah, no, doesn't seem significant.
Okay.
So maybe what we can do is, this is actually interesting. We can also explore visually these different options. What we can also do is just to build a model and try to see if
Oh, that would be great.
the personality traits maybe are predictive of success performance for in the platform. So maybe some students start goal because just for behavioral reason, then you can know in advance that maybe they need better support or things like that.
Mm-hmm. Yeah.
All right, so let me try to use the AutoML here, and then I'm gonna give the AutoML part as an input, and then predict success, and then based on all the features, I think that you can also, yeah, okay, perfect. I can see your video bubble now. So I'm gonna remove all the information here: audio, student, unit average, stars, hint, term code, period code. I just really want to use the start time, class level, completion time. Yeah, so I'm just literally using all the personality traits part.
Mm-hmm.
So I'm just remove all the attributes that came from the original table and just keeping the target success, and I'm using just the personality ones. And then in this case, the success is just, we can just do from binary, makes sense in this case. And then we can give 5 minutes, but we can check the results as soon as they come back.
And so this will be checking success against all of the personality traits then?
Yeah.
Oh, interesting.
So it's not going to be, of course, like it's going to be a hard task for the AutoML, because we're literally saying, like, based on the personality traits of the student, tell me how successful would be, right? And so it's likely to be so deterministic in certain sense. So I expect quite a level of non-deterministics.
Okay.
Here. And so the results are actually better than the naive score. That means that if the score that you will get if you just predict the majority class. But what I found interesting here is mostly the ranking of the feature importance across all the attributes. So, and I want to discuss with you this because it's gonna give us like a ranking of which are the most predictive factors. And
okay, interesting. So what you've done then is you've used the AutoML to try different pipelines, and now you're doing the explanation of the best pipeline that it found. Is that right?
Yeah.
And these are kind of the most salient features then.
The AutoML is still running, but in the meantime, we can start exploring this one, which like it's just explaining. It's good because it's telling us in relative terms for the attributes that we saw. which are the most important one. I'm sure that if we use something that is more connected to the task itself,
Mhm.
those features will dominate on personality, right? Because it makes sense that if audio is really hard, then it's not going to be a successful session. And
Mhm.
if it's really easy, then it's going to be successful. So I
Right,
think that's
right.
what dictates this type of phenomena. But it's interesting to see that even just the personality traits and the ranking, the relative ranking, it's kind of interesting. And I remember you were talking about conscientiousness, and
Mhm.
seems to be there at the top two.
Right, right. And interesting is that social boldness is the highest ranked one in there. That's interesting. I hadn't expected that to see that. The conscientious one kind of is in line with previous research, but social boldness is kind of a surprising one to come out on that. Yeah,
Yeah.
interesting.
All right. So maybe like once this analysis is done, I know that you're researching on this. A couple of options you can either, as you can see also the AutoML while we were talking, found a better performing pipeline. So we didn't get stuck during the conversation, but I
Hmm.
think we covered a lot of the points that we discussed at the beginning, going from data manipulation to the evaluation metric of success, and then finally building a model to try and understand how the personality traits, kind of how predictive they are of a successful session.
Yeah,
um,
Benedetta, this is great. I love kind of the being able to hone in on the success metrics. That's something that when I was coming into this, I thought would be really difficult because there's so many different kind of balls in the air
Aspect.
about identifying it. And this really has been great to kind of see the process about how to go through into this, the modeling even at the end
Yeah.
too.
Yeah, I mean, it was a pleasure really to collaborate together, and it was super interesting as a use case and to explore like you know, the experimentation of this new tool and finding new ways to help students essentially to improve with peer feedback. It's a really cool exploration. All right, so thank you very much, Tom, and yeah, thank you again for joining the session.
Hey, thanks a lot. And I really am enjoying working with Imlic on this. So cheers. Thanks for all your help.
Bye bye.
Take care.
All right, I think that
All
I'm
right.
gonna stop the session.